Hi, I'm Phil Dworsky, and welcome to the 50th DAC, the Synopsys booth. I'm joined by Tim Whitfield from ARM.
Hi.
Tim is the Hsinchu Design Center Manager. And I think we have a number of things to talk about that cross a number of different areas, both ARM and Synopsys technology. I know that we worked together on a graphics processor implementation in 20 SoC TSMC technology. Why don't you talk a little bit about some of the challenges involved in both of those areas, both GPU and in the physical side?
Okay, yeah, we spent a good deal of time last year looking at Mali graphics processors and 20 nanometer design node, and there are some differences between traditional CPU implementation that we see with ARM and the Mali graphics.
You know, I think we spent a lot of time, many years in fact, working on CPU implementation, and suddenly we're challenged with a graphics processor that's maybe 8-10 times as large and maybe similarly complex.
That's correct, yes. I think the design community, the ARM design community, is very familiar with the CPU. When we move to the GPU, there are many, many more options to think about. There's the complexity of the size, which of course brings challenges with tool run times and also memory footprint within the tools. But there are also challenges about configuration. So whereas previously you might be deciding between 2 or 4 core CPU, in GPU it might be 1, 2, 4, 8, 16 cores. There are a number of things to think about. And instead of looking at pure performance, we're often looking at balancing power with performance, so trying to decide whether we want a many core implementation with a low power implementation point, or whether we're going for a single or dual core implementation with a very high performance point.
Right.
So we have to think about those system challenges, which we didn't have to think about previously.
And I think we only complicate things further when we look at the routability challenges of that core, or those cores, crossed with 20 nanometer technology and below.
Absolutely. So one of the unique differences with the GPU is the routing complexity. So if you look at the architecture of a GPU, it lends itself, unfortunately, to routing congestion. And if you look at the 20 nanometer design node, then the complexities of the double patterning and the very high density wiring means that the problem is essentially compounded. So we have to work very closely both with the CPU designers at the architecture stage and also with Synopsys on the tool implementation phase to make sure that the libraries, that the tools, and that the logical IP all work
and the
together.
Process, right? I mean, it's all interconnected.
Absolutely.
I think that one of the key messages from our teams working together was the need to explore early and often and try to knock out problems at the front end. And I think that's one of the key messages of the talks that you've given on that.
Yes, we certainly looked at how we identify some of the downstream implementation challenges very early. So when you're talking about 7 to 10 day implementation spins, we don't want to get 7 days into an implementation to find that we have an unresolvable problem. So some of the features that are available in the Synopsys tools have really helped us to pull those issues up front, understand where we're going to see issues downstream, and make sure that we're not wasting time just turning the handle, and that we see those problems very early.
I think one of the benefits of your co-location, and our co-location with TSMC in this case, was the ability to collaborate starting at the 0.05 level of process readiness. And I think that really couples into addressing our customers' challenges before they have to face these kind of issues.
Absolutely. I mean, one of the reasons that ARM established the design center in Hsinchu was to work very closely with the process guys and ready that ecosystem. So the idea is to really resolve the problems that our customers will see way before they get to them. So in the past, we may have given tools, physical IP, logical IP as almost 3 separate packages and said go figure, with a little bit of help in reference methodology. Now we're trying to get there right at the beginning and make sure that we can influence the process decisions, we can influence the tool decisions, and influence the physical and logical IP.
And I think that co-optimization is what benefits our customers as well, having the co-optimization done and the readiness when they receive the solutions.
That's certainly the plan.
That's right.
We work very hard at making sure that they don't see the problems that we have to resolve, and that they still get those time to market advantages when they're moving to very advanced nodes. There are clearly some additional technical challenges. We want to hide as many of those from our partners with your help, and also through our work we're doing with TSMC.
Now, I recognize you announced today another low power core, a smaller core aimed at a low power market, and in the Mali area. And I think that presents again this kind of trade-off balance where you've got some processors that can be tuned to a lot of different points, and you have now yet another point to address.
Yeah, certainly. I mean, Mali graphics is no different from CPU. You need the right GPU for the right task. So we have a range of offerings that enable us to do very focused implementations for the mobile space, and also very high-end implementations for both the mobile space where required and also for GPU compute. So it's all about using the right processor for the right job, similar to the big. LITTLE in CPU. GPU similarly has those offerings. You need that right GPU.
So when we announced the collaborative results, we talked about having trailblazed on the 20 SoC path, but also working together forward-looking on optimizing implementations. I'm looking forward to seeing those results and delivering those to our customers as well.
Absolutely. Well, we've just received the silicon back, so we will get some silicon results.
Fantastic.
And we'll certainly be looking at what the next steps are.
All right. Well, have a great DAC, and thanks for collaborating.
Thank you very much.
Thanks for your time here.
Good to work with you.
Cheers.